for next week. This is for, today is the 6th, isn't it? So 13. So number one, so if we look at this, there's a couple of things I have to realise. One is that there's a division in there, and if I want to get rid of the division, I'll multiply both sides by D. And the other thing is that D occurs twice. And we'll see that that involves getting all the terms involving D on the same side and then factorising, which means to take the D outside the bracket. So that's a very common thing. If the thing you're trying to isolate occurs more than once, what should occur to you is at some point you have to get all those terms involving D or whatever it is together and then factorise it. And then the D will be on its own. You'll see that work. So, first thing to do, if it's divided by D, multiply. It looks like this right-hand side, if we look at it, the last thing that happened was it was all divided by D. And so, multiply by D. If I multiply both sides by D, the right-hand side will look like YD, Y times D. And then that equals lambda x minus D. And because I've multiplied by D, the divide by D disappears. So I'm just left with that. Okay. Focusing on this. Now, I've got a choice. I can go two ways from here. I can either multiply out this bracket on the right-hand side, or I can divide by lambda. And I'm going to go through it both ways, and then you can decide for yourself which way to use this. We'll compare the answers and see that they are actually the same. So the first way I'm going to do it, so let's divide the paper or the board into two parts, so I can go down the two routes. Let's first of all multiply out the brackets. So if on the right hand side I multiply out the brackets, that means every term inside the brackets is multiplied by every term outside. Multiply out the brackets. Another little thing that comes up a lot in these things, the first one was that we've used already, was if it's all divided by something, multiply to get rid of it. The next thing is, if what I'm after the D, remembering here, if the D, or the term involving D, is negative, which is in this case, is the negative sign, then add it to both sides to make it positive. So I'm going to add this whole term to both sides. YD plus lambda D equals lambda x. I've actually also, I'd have done that anyway, because the next thing, once I've got D out, so I'm looking at this line again here, is to get all the terms, as I said at the beginning, involving what we're after on the side together on the same side. And that's what I've done here. I've got all the terms involving D on the same side. Now I factorise. And that means take outside a bracket what's common to both. D is common to both of these terms, so take it outside the bracket. And then what am I left with inside the bracket? I ask myself, what have I got to times this D by here to get Y times D? So Y is left inside. What have I got to times D by to get lambda D? So Y plus lambda is left inside the bracket equals factorise it. Now D is multiplied by that whole bracket, Y plus lambda. So to get rid of the bracket, divide. Divide both sides by Y plus lambda to get rid of that whole bracket on the left hand side, and we get that D equals lambda x, all divided by Y plus lambda. And that's the solution. Okay, that's one way to do it. Now let's look at the other way to do it. So going back to this point here, before we decided to multiply out the brackets, the other thing we could have done was to divide both sides by lambda. So yd divided by lambda equals x minus d, because I've got rid of the multiply by lambda, so I don't need the brackets anymore. Now I want to get terms involving d on the same side, so add d to both sides to get rid of that minus d on the right hand side, and get yd over lambda plus d equals x. And then I factorise. Take d outside the bracket. What have I got to multiply d by now to get back to this term y over lambda? I've got to multiply by y over lambda. So that's what's left inside the bracket, y over lambda. Plus, what have I got to multiply d by to get d? 1 equals x. Now, get d on its own, divide both sides by y over lambda plus 1. So d equals x over this bracket, y over lambda plus 1. Okay, now this next part is not straightforward. It's a little bit of algebra that we're going to be talking more about when we look at assignment 1. So I said at the start, didn't I, that you get the same answer. So actually, looking at this lambda x over y plus lambda is the same as x over y over lambda plus 1 in theory, if we've done this thing correctly. So it's now a case of showing that it's are the same. And that's not straightforward actually. Well, we've got something like this. Let's look at the bottom of this fraction here, y over lambda plus 1, this part. Whenever I have two fractions, y over lambda plus 1, and I add things together, we talked about this at the beginning of the course, whenever you add, you must have the same denominator. So what I need to do is to think of this as, let's leave the x as it is, y over lambda plus lambda over lambda, which might not be an obvious thing to you to do, but what I've done is I've made the denominator the same in both of these. And 1 is just one thing divided by itself, isn't it? 3 divided by 3 is 1, 4 divided by 4 is 1, lambda divided by lambda is 1. So I just call 1 lambda over lambda. And now I've got the same denominator, and I can say that this equals y plus lambda all over lambda. When you add fractions, denominator, you don't add the denominators, do you? 1/3 plus 2/3 is 3/3. Y over lambda plus lambda over lambda is y plus lambda. And this is, there's some quite some algebra here. If you're seeing where I'm going, good. If you're not sure, hopefully we will start to see it as we go through the course. Hey Jordan, I can see you smiling broadly. The next thing to come out of this is another thing to do with fractions. When you divide by a fraction, you invert and multiply. You may remember doing this at school. If I divide by a fraction, I invert the second fraction and multiply. So this actually becomes x times this bottom fraction inverted, lambda over y plus lambda. And then you can see that it's the same as that, x times lambda over y plus lambda. So they are actually now the same. Yeah. it's probably easier to do it the left-hand way, but I just wanted to demonstrate that you can actually go either way and you get the same answer. But I agree, the answer is not straightforward there. And so that brings me to another point, which is if you're doing something to rearrange a formula and the algebra is starting to get hard, think maybe there is another way to do this, an easy way to do it. Possibly there is, as we've seen here. So yeah, I would agree, go with the left-hand way. Multiply out the brackets. So question number 2. Resistance R equals R0. This is a very common sort of abbreviation to use. You may have come across it already. A little subscript here to represent a resistance at temperature 0 or time 0, something like that. This is probably temperature, because this formula looks like something to do with to find the resistance of the material as the temperature changes. So T probably is going to represent temperature, and alpha would be this coefficient of resistivity, which is the rate at which the resistance changes with temperature. So there's the formula anyway. R equals R0 brackets 1 plus alpha T. We've got to rearrange this for T. So easier because T only occurs once, so we haven't got to do any factorising. All we've got to do is get T on its own. Two ways we could go. One way would be to divide by R0 and then get rid of what's left, and the other way would be to multiply out the brackets. And again, both ways work, and both ways would give the same answer, but might need a little bit of fiddling to show that they're the same. So what might we do? What's the first way we might go? Anybody? Multiply out the brackets? Right, okay. R equals R0 times 1 is R0 plus R0 times alpha T, R0 alpha T. Remember we're after T. So looking at the right-hand side, what would you get rid of first? The R0. Yeah. Because we've got this whole term here, R0 alpha T. So what's happened here? T, which is what we have to remember, has been multiplied by R0 alpha, and then the R0 has been added. So first of all, get rid of the R0. Subtract it. R minus R0 equals R0 alpha T. Now next, T has been multiplied by R0 alpha, so divide. So, dividing the left-hand side by R0 alpha, I just rewrite what's there, R minus R0, and divide by R0 equals T. So that's the answer. T equals R minus R0 over R0. Instead of multiplying out the brackets, what's the other way I could go on with starting at this point here? What could I have done? I could have divided by, so this whole bracket here, look, is multiplied by R0. So divide by R0. And I get R over R0 equals 1 plus alpha T. Now we're in a similar situation to the one we were in a second ago. Look at T, it's been multiplied by alpha and then 1 plus. First we'll get rid of the 1. R over R0 minus 1 equals alpha T. And then divide both sides by alpha. So we get that R over R0 minus 1 all over alpha equals T. And that would be the answer. But that doesn't look anywhere near as convenient as the left hand side, does it, as a useful formula to use. And using a similar method to the one we used on the last question, you could show that this method, or this answer here, is the same as this, and I'll leave you to try and do that if you want to. Same approach. What we need is a common denominator on the top here. So have a go, okay? Okay, so number 3, this is to do with the time for the swing of a pendulum, or anything that's oscillating backwards and forwards just due to gravity. So G in this formula means the acceleration due to gravity. L represents the length of this thing that's oscillating backwards and forwards, and T is the time for one swing of a pendulum, or it's a period. We've got to rearrange it to find L, the length of it, given the other values we could find L. So we've got to get L on its own. If you look at it, L is divided by G and then it's square rooted, so it's inside quite a lot of things in here. But what we do is, let's just get rid of the 2 pi and then worry about what to do with the square roots afterwards. So first thing I would do is get rid of the 2 pi, divide both sides by 2 pi. T divided by 2 pi equals the square root of L over G. Divide both sides by 2 pi. What do you do to get rid of the square root? Square. So if I square the right hand side, I get rid of that square root symbol. But I've got to square the other side. So to show that, I just put a bracket round the whole of this thing, T over 2 pi, and square it. Equals L over G. And now we're virtually there. The length L is divided by G, so multiplied by G to get rid of it. And we're left with L equals G times T over 2 pi squared. I've just written it the other way around with L, the subject, first. Number 4, quite soon, and when we move on to assignment number 1, we're going to be looking at the algebra, and as I say, we've looked at 1 or 2 things like this already. Simplify this expression. Okay, so to simplify this, the steps that are involved are to expand out the brackets and then collect like terms. All the terms involving x and all the terms involving y. And hopefully it will be a lot more straightforward then. To multiply out the brackets, what that means is I'm going to multiply every term inside this bracket by x, and then I'm going to multiply every term in this bracket by minus 2x. And that minus 2x has got a consequence, so we have to be careful with that one. And then we put them together. So let's have a look. So here's the first bracket first. X times 2x, 2x squared. X times minus 4, minus 4. I could have written minus 4yx here, but we tend to write numbers first and then letters alphabetically, so xy. Now the next one is the one we've got to be careful of. Minus 2x times 4x is minus 8x squared. And then minus 2x times y gives minus 2xy. So be careful of the signs here. Okay, we get to that point. Now we collect like terms. I've got 2 lots of x squared minus 8 lots of x squared gives me minus 6 lots of x squared. Nice. Minus 6 lots of x squared. Minus 4xy minus 2xy minus 6. No. Minus 4 minus another 2 minus 6 minus 6xy. then that's certainly simplified. This expression looks a lot more straightforward than this top one here, but we can go a step further, and that's to factorise, because x is common to both of these terms, and so is minus 6. So I can take minus 6x outside the bracket. So what have I got to times minus 6x by to get minus 6x? And the next one's the interesting one. What have I got to times minus 6x by to get minus 6x? Plus y or minus y? Plus y. You're right. Yeah, okay? So be careful again of the signs. Once you factorise, and you'll be doing this sort of thing in the assignments, I would always recommend that once you think you've factorised it, in other words here, multiply this back out and check to get back to this again. Minus 6x times x is minus 6x squared, minus 6x times y is minus 6xy. So you can check that you've done it correctly. And that would be a simplified version. Okay, last question for next week. Just a memory test. Write down the formulae for the area and the circumference of a circle. What's the formula for the area of a circle? Area of a circle. Pi r squared. And formula for the circumference of a circle. 2 pi r or pi d. Both of which are equal. So just remembering some basic formulas. And that will be the drill for next week.